Today's daily code problem of the day is maximum width ramp number 962. A ramp in an integer array nums is a pair of numbers I and j for which I value is less than j's value and the value of nums of I is less than or equal to the value of nums of j. The width of such a ramp is j minus I. So we're given an integer array nums, and we want to return the maximum width of a ramp in nums. So if there's no ramp, it'll just return 0. What does this mean? A ramp is simply the distance between two numbers in an array. So the maximum width ramp in example 1 would be from index 1 to index 5. And that's because 0 is our I value, so I is less than j. The position is I, so 1 is less than j, which is 5. And nums of I is equal to 0, where nums of j is equal to 5. So this is the maximum width ramp that we can create with this array. If we started at 1, we could only get to 5. If we start at 2, we go to 5. 8, we can't make a ramp. 6, we go to 8, because we're looking for something that's either bigger than or equal to that number. For example 2, our maximum width ramp is 7. That's because we go from 0, 1, index 2 till index 9. This works because nums of I is equal to nums of j. So, for this problem, we're going to use a monotonic stack. A monotonic stack is going to consider the indices of all the elements and all the preceding elements for nums of I. Say nums of I is element 2. So we'll find all the indices by maintaining a monotonic stack, and we're going to encounter each value in the stack, and we will only push an indice onto a stack if its value at that current index is smaller than or equal to the value at the index of the top of the stack. So this ensures that the stack contains a list of potential starting points for the ramps. So in this case, we would push 6, and then 0 is less than 6, so we'll push 0. But because 8 is not less than 0, we won't push that, we won't push 2, we won't push 1, we won't push 5. And then we can do a for loop going backwards through our string array and find the distance between 5 and 0. That's the maximum distance, so we can pop 0. We will then do the same thing for 6 because it's the next thing in the stack. And we won't be able to find anything until 8, which is going to be smaller than our current ramp. We'll basically just do that until we find the longest ramp. So for this, we're first going to initialize a couple variables. We will have the length of our nums array, so integer length will be equal to nums.length, and then we will create a new stack of integers, and we could call this our index stack. This stack is going to keep track of the indexes of the numbers that are either our potential starting points for our ramp. We can then fill our stack with indices that are potential starting points by having a for loop for int I is equal to 0. As long as I is less than our length, I can increase. And then if our index stack is empty, we will want to automatically push something in. Otherwise, if our nums of the index stack dot peak, remember we're going to check the very top element, is greater than nums of I, we can push this onto the stack. So this for loop is going to increment through each value in nums. If either our stack is empty, meaning we're on our first element, or the nums of index stack, so if say we're at I is equal to 1, so stack.peak would be equal to 6. So if nums of I is greater than or less than whatever is at the top of the stack. So 0 is less than 6, which is at the top of the stack. We will then push that onto the stack. So we will only ever add things that are smaller than what's at the top of the stack. Then we can create a value int max, which is going to keep track of our max ramp length. And then we can simply increment throughout the array from the back. So now that we have our stack for example 1 is going to be 6, 0. We're going to start with 0 and we're going to compare it to 5. And so the distance between these two elements is 4, because that's the longest possible combination for a ramp. For 0, we can pop 0 and then move on to addressing possible combinations for 6. So 5, no. 1, no. 2, no. 8, yes. However, this is smaller than 4. And now there's nothing else on our stack to address. So we will traverse the array backwards. So for int j is equal to the length of our array minus 1. As long as j is greater than or equal to 0, j will decrease by 1. And while the stack is not empty, so index stack dot is empty, and our nums of index stack dot peak is less than or equal to nums of j, then we can increment our max width. So max width will be equal to math.min of max width. Sorry, we're just calling it max. Max or, so it's either going to be max or j minus the current index at the top of our stack. So index stack dot peak. Then, because we updated our new max value, we can pop that value in our stack. So index stack dot pop. Again, this is a for loop that's going to traverse our array backwards. And while our index stack isn't empty and the number at the top of our stack is either less than or equal to whatever index we're on, then we can update our max value. So if 0 is at the top of our stack, we're going to check the length at 5, because 5 is 4 long. That's our new max. And then we're going to pop 0. We will then look at 6. Is 5 less than 6? No. Is 1 less than 6? No. Is 2 less than 6? No. Is 8 less than 6? Yes. So then we'll update our max and pop 6. So by returning our max value and running this, this passes our test cases, and if we submit it, this passes all solutions. So thank you, and follow for more daily LeetCode solutions.